quadratic inequalities, but this time we're going to make a system, like a system of inequalities to start. So we want to know we have x squared plus 3x minus 6 is less than or equal to x plus 2. So what we actually have, before we start graphing, I'll write this here. On the left-hand side where x squared is, that's a parabola, right? That's the equation of a parabola. And the x plus 2 is the equation of a line. So we're going to be comparing a parabola to a line. So what I want you to do to start is not worry about the inequality symbol or anything like that. I want you to graph x squared plus 3x minus 6. Graph it on your calculator. So use your table, plot all the points. Graph it accurately, and then also graph x plus 2, the line, on the same axis. So that's the first thing I want you to do. I'll give you a couple minutes there. We want to know, this says, basically I'll say it in non-math language, where is the parabola less than or equal to the line? So if I'm not looking where the parabola is less than or equal to the line, am I looking where the parabola is above or below the line? Below. So here, although my highlighter is freezing again, I'm looking at this part, and I know the pen will be frozen too. But it looks like that part of the graph is below the line. There we go. We're looking at the line. We're comparing the two graphs this time. So when I look at this, where are the points of intersection? Where do these graphs intersect? What ordered pair? -4, -2, and 2, 4. Okay, so what I'm looking at here is I still need to write a solution. Now, I just didn't have room to put the number line and the interval and everything on here. So we're just going to look at set notation. But we can start by doing the same thing we did yesterday, by making a number line on the axis. So if I were to make a number line here, what kind of dots would I use for less than or equal to? Closed dot. So I'm going to put a closed dot on the x-axis at this x value on the right here of 2. So I'm just making an x-axis, or a dot on the x-axis, like this is my number line. And where would the other dot on my x-axis go? -4, because that's the x value that these graphs intersect at over here. Now I'm pretending that that is my number line so I can find the solution set here. So just like yesterday, when I had one part of my graph shaded, do I color in between those dots to make one part of my number line, or shade out to make 2? Is the solution set in between the dots? Yeah. Or is it outside the dots? In between. So if I make that kind of like my number line, I can see that there's one part to my number line, just like there's one part of my parabola that I highlighted here. So if I make my set notation, that's the inequality. What inequality would I write to represent this solution set right here? -4 is less than or equal to x, less than or equal to 2. So go. Yeah, you can do that. But I just have those points there so we could like see. It doesn't matter. Yeah, you can do it. And however you want. So our solutions at the x values from -4 to 2 are where the parabola is always graphed underneath the line. Now that's one way to do this problem. The second way I want to look at is I want you to solve this original inequality for 0. All right, so let's rewrite the original, and then we'll talk about what that means. Right? If I'm going to solve this for 0, that means I'm going to get one side of the inequality equal to 0. It does not matter which side. So what's going to be easier to move here? X plus 2. So if I move this, I'm going to subtract x from both sides. And I'm going to do it in the same step. I'm also going to subtract 2. Okay? Which is easier, saves a little bit of room. That makes the right-hand side cancel off to be 0. And the left-hand side becomes x squared. 3 minus 1 is 2x minus 8. So now this looks a lot like what we did yesterday. I have a quadratic, an inequality symbol, and 0. order to graph this, I need to factor. I need to find the x-intercept. So how do I factor the left-hand side here? What two numbers multiply to -8 and add to 2? +4 and -2, yeah. So I have x plus 4 and x minus 2, which if I use the zero product law, what x-intercepts do I get? -4 and 2. Well, what do you notice about those x-intercepts already? They're the same numbers as what I used over here for the x's of the point of intersection. Oh. So now I have to sketch a graph. So I want you to think about if my graph opens up or down. So when you do that, look at the x value here once it's set equal to 0. Is that x value positive or negative? In front. It's positive. So will my graph open up or down? Up. So you're going to graph a parabola here that opens up through those x-intercepts. I don't have to worry about plotting the rest of it. I'm only interested in the x-intercepts. And then we do what we did yesterday. I want to know, where is my graph? Here it says less than or equal to 0. So does that mean above or below the x-axis? This one here would be below. And just like we talked about in the other problem, how many parts to my graph did I shade here? 1. So if I go onto the x-axis, I'm going to put closed dots at my x-intercepts because it says less than or equal to, and the equal to means closed. And would you shade in between those dots for your solution set or outside? In between, right? Because I have one green portion, I need one part of my number line. So this allows me to see my set notation solution is going to be exactly the same as my other set notation solution. My inequality is -4 is less than or equal to x is less than or equal to 2. And how do we write that solution set in interval notation then? I do.
I'm only kidding. It's brackets. -4, comma 2 bracket.
Good. Right, does this kind of make sense?
Yes.
All right, so there's 2 ways to do this. We'll pick which one we like better in a minute, but we got to do one more. We're only going to, we're not going to do the back. We're only doing the front today. Not making you do the back. So, on bottom, I want you to now take a minute again. Take your calculators. We have 2 parabolas this time. I have -x squared is less than x squared minus 4x minus 6. So, take a minute, graph both. You probably, or I'm hoping, based on... You good? On the ACT? Yeah, there is some trig and stuff though, so pre-calc is, like, you'll have more... Here, I'll post this. Let's look at this one. We're almost done, guys. Yes. Great. So, we have 2 parabolas here. And what we're looking at is we want to know, where is the upside down, -x squared, that parabola, less than the other parabola. So we want to know, where's the upside down parabola underneath? Bobby?
Is it just the minus 1, 1?
Yeah, at that intersection point, so right over here. So how many parts of that negative parabola are underneath the other one? Not all of it. I don't know why my thing keeps freezing, but... So we're looking for where the upside down one is underneath the other one. Oh, there we go. All right, so it looks like it's like this portion of the graph and this portion of the graph are underneath the other parabola. So if I look at the intersection points, Bobby's right, that happens at 1, -1, and, I'm sorry, yeah, -1, -1, and 2 negative, or 3 -9? Is that right? So if I have 2, yes, Taylor? You look at the symbol. So this says less than, so less than means below. So I have 2 parts here, right? So when I write my inequality, well, I want 2 inequalities or 1? 2. Now, if it helps you, make a little number line on your x-axis here. What kind of dot, open or closed, is going to go at the x value of -1? Open. So I put a little open dot here, and I will shade out to the left because that represents the x's to the left on that yellow part. And then I'll also put an open dot at 3, that's where the intersect, and go out the other way. So that gives me 2 portions of my number line, just like there's 2 yellow portions of my graph highlighted. Now when I do set notation, what inequality do I write to represent the left portion? X is less than -1. Then we write the word or. What's the other inequality? Yep. So that's your solution set. Now, just like the last problem, we want to do this the other way, so then we can choose which way works better for us. So start again by rewriting the equation. Negative x squared is less than x squared minus 4x minus 6. Which side do you think is easier to move? The negative x squared. So I'm going to add x squared here. And when I add x squared, I get 0 is less than 2x squared minus 4x minus 6. I'm going to pull out a GCF, right? So I'll have 0 is less than 2 times x squared minus 2x minus 3. And how does that factor in the trinomial? What's your numbers? Multiply -3 and add to -2. -3 and 1. Good. So from there, I can find my x-intercepts. Where are my 2 x-intercepts? 3 and -1. And again, are those the same x's that we had as intersection points over here? Yes. Now, look at your parabola. Look here at this guy. It's a +2. So is your parabola going to open up or down? Up, because this is positive right here. So I'm going to draw a parabola opening up through those 2 dots, and it doesn't have to be perfect, just through the x-intercepts. And finally, I want you to be really careful reading the inequality symbol here, because the 0's on the left this time. This says we're 0 less than the parabola. So does that mean the parabola is, do we want to find where it's greater than 0 or less than 0? It's next to the big part, right? So the parabola, we want it to be above or below the axis? Above. So it's trickier when the 0 is on the left, right? This says we're 0 less than the parabola, or where's the parabola greater than 0, if you read it backwards. Are you okay with that? Just have to be careful. Again, I have 2 parts here, which means I would put open dots because I have a strict inequality at my x-intercepts, and because there's 2, do I shade in between or out? Out again, right? And it looks like that number line is the same as what I did in part A. And I would have the same solution set and set notation that I already wrote. So my solution is all the x's less than -1, or the x's greater than 3. How do I write that as an interval? Parentheses, -infinity, right? -infinity up to -1. Okay, -infinity to -1. What symbol goes in between? Union. What's the other interval? 3 to infinity. Okay? Yes. For the interval? What do you mean by that question? I mean, yes, we read inequalities left to right, but okay, I literally dropped mine down like behind like the stairs over here. There's a crack in the wall. I literally dropped it like 2 stories today, and it's all good. My calculator. I made a really loud crash, but it turns on now. Because, so this is asking where is the upside down, the negative parabola, less than. So so small sides first, so it's less than the other parabola. You could. It would be the same thing though. If you looked the other way and you said, where's the other parabola bigger than the upside down one? It still gives you the same answer. It's this part right here. Wait, no, it's not. It's this part right here. Let me highlight it. It'd be this and this, right? These are above the other parabola, and it will give you the same solution. Yeah. one last thing, and then we'll start on the practice. Which method did you guys like better? Ultimately, it does not matter whether you like to graph both equations and make a pretty system, or if you like to solve for zero and factor. I do not care what it is that you like to do. Pick your favorite method, get good at it, and then just do that one, okay? So here's what I have for you today. I'm going to give you a little